Hello students, in today's video, let us learn about the fundamental particles of nature. So you have a broad understanding about how the idea of atoms as the constituent particles as the fundamental unit of all matter in nature evolved over time. For example, in the ancient times in Greek, they had this philosophy that all matter is made up of four basic elements, which are air, fire, water and earth. So then they tried to understand the working of the nature based on these four elementary particles. But later, this was a very naive idea. Later, very broad and scientific principles started to evolve about the constituent particles of matter. For example, John Dalton was the first person to scientifically propose that atoms are the basic constituent particles of all matter. But even before that, in the theories proposed by great Indian scientists like Kanada, we can see the concept of Paramanu, where the concept of atom is being proposed. But John Dalton is widely accepted as the first person to propose that the atoms are the constituent or the basic elementary units of all matter. Now, at that time, Dalton did not have the idea that the atoms can be further divided. Dalton proposed that atoms are indivisible units, but later it was found that the atoms can be further divided into small units. For example, in 1897, J.J. Thomson, an English physicist, discovered electrons within the atoms. In the famous cathode ray experiment, it was found that atoms contain certain constituent particles within them, and the concept of electrons as the constituent particles within the atom evolved. So electrons are negatively charged particles which are lighter than the atoms. Now later, the constituent particles within the atom were studied more comprehensively, and it was found that there are some positively charged particles within the atom itself, within the atom, and that makes the atom as a whole neutral. So J.J. Thomson proposed that the structure of the atom will be like a plum pudding model. So he proposed that the electrons are distributed evenly within the atom. But later, Rutherford, in his famous experiment of alpha particle scattering experiment, found that there is a central part of the atom called the nucleus, where the positive charge is concentrated, and surrounding this, the electrons are actually orbiting. So the Rutherford's model of atom was developed based on the scattering of electrons from the gold plate. So he found that in the center we have nucleus, and surrounding this, electrons are orbiting. Now then the scientists had this idea that the neutron and proton might be fundamental particles. So there cannot be any further subdivision within this. But is that true? Neutron and proton, can we further divide them? So let us have a look into that. So when we come into the picture of the fundamental particles in nature, a lot of discoveries were made in the 19th, especially in the 20th century. For example, the studies on the cosmic rays that comes from stars and especially from the sun resulted in discovering a lot of other fundamental particles, a lot of new particles. For example, we know the cosmic rays from the sun often carries the nucleus of helium, which is the alpha particle, and the protons, which is the nucleus of hydrogen from the sun. These particles are also emitted with the solar flux that is often emitted from the sun. When these alpha particles and the protons coming from the sun interact with the atmosphere, they produce a variety of particles such as pions, which is represented by pi, then muons, which is represented by mu. So scientists had this idea that there are some other kind of fundamental particles like pions, muons, etc. And these were first discovered from cosmic rays that is coming from the sun and other stars. So the idea of existence of other fundamental particles was brought into picture. Now later, another important study with regarding to fundamental particle was the discovery of neutrinos. So in a famous experiment on the decay of nucleus, the beta decay of nucleus, it was found that there are some other particles that are actually emitted together with the beta particles. So beta particles are electrons. So when nucleus emits electrons during beta decay, a process of nuclear reaction, there are some other particles that are actually involved in this process. Scientist named Pauli proposed that a new kind of particles called neutrinos are there, and these particles are actually involved in these kinds of beta decay reactions. So this is another important milestone regarding the discovery of another set of fundamental particles. So we have seen that in the earlier times we had a very broad idea about atoms. Later we got a picture about neutron and proton, and now during the 20th century a lot of other discoveries are being made, from the invention of cosmic rays and the constituent particles, and later the discovery of neutrinos in the 20th century. Now coming to the structure of proton and neutron, as we have mentioned, even the proton and neutron are not fundamental particles. They can be again further divided. So if you look into the proton, you can see that there are 3 constituent particles, and within the neutron there are also other 3 different particles. We will have a look at that in detail. So as of now we can understand that the protons and neutrons are not fundamental particles. They are actually composed of some other particles. So let us come into this standard model of elementary particles. So here we can see 12 particles that are arranged, and 6 of them are called quarks and the other 6 are called leptons. So altogether these 12 particles, which are the elementary particles, constitute all matter in the universe. So as of now we have told that all matter is made up of atoms, and atoms are made up of protons, neutrons and electrons. But now we are getting a picture that the matter is made up of even still fundamental particles, and we can broadly classify them as quarks and leptons. Now let us understand what are quarks and what are leptons. So quarks, there are 6 different types of quarks, and they are up, down, charm, strange and top, bottom. So these are the names of the 6 different quarks we have. And these are quarks, and the major property of these quarks are, the major property is that these quarks are involved in strong nuclear force. And or we may call it strong interaction. So what are the other properties of these quarks? So if we look into that, these top group U, C and T, their charge is plus 2 by 3. And for D, S and B, their charge is minus 1 by 3. And if you look into the structure of a proton is made up of 2 up quarks and 1 down quark. So what will be the total charge of a proton? The charge of an up quark is plus 2 by 3. So we have 2 plus 2 by 3 in a proton. So it is 2 by 3 plus 2 by 3, and 1 down quark whose charge is minus 1 by 3. So the effective charge of a proton is plus 1. Similarly, can you calculate the total charge of a neutron based on the constituent particles? For up quark, we have 2 by 3 charge. For one down quark, we have minus 1 by 3 charge. And for the other one, we have minus 1 by 3. So the total charge is 0. So generally, we have these 6 different quarks, and we have seen how up quark and down quark can constitute protons and neutrons. And see, these 6 different quarks can interact and form other particles, other constituent particles. So these are the elementary quarks, one set of elementary particles that we have studied. We have learned about their properties and their charge. Now coming to the second group, the leptons. You already know one member of this family. It is the electron. Electron is a member of this family, and electron is a fundamental particle. We know neutron and proton are not fundamental particles because they are composed of even still smaller fragments, but electron is a fundamental particle. Now, just like electron have other cousin brothers. They are muon and tau or the tau lepton. So these particles have a charge of -1 or -e, just like the electron, but they have different masses. Electron, muon and tau lepton have different masses, and they behave just like the electrons. Now within this family, each of these electrons have electron, muon and tau lepton have an associated neutrino. For example, electron have an electron neutrino associated with it. Then muon neutrino, which is another fundamental particle, and tau neutrino, which is another fundamental particle. So we can classify these together as one family. Muon and muon neutrino as second family, and tau neutrino as the third family. Now, all these particles that we have mentioned, quarks and leptons, have a property called spin, which is an intrinsic property of these particles, and the spin of all these particles are equal to 1 by 2. So these particles with half or 3 by 2 or odd integral multiples of 1 by 2 as spins are broadly called fermions. So we can say that these quarks and leptons actually belong to a class of fermions. Now with quarks and leptons, we cover all the important elementary particles that actually constitute all the matter that we see in the universe. There are also other particles that are involved in the interaction between these particles. You know about various different forces that exist between particles, right? The gravitational force, the electromagnetic force, the strong and weak nuclear forces, etc. So there are also other particles called bosons that are associated with these interactions. For example, you might have heard about the particle called photon. So photon is associated with electromagnetic interaction, EM waves. Then you might have heard about gluons or Higgs bosons. They are actually related to the gravitational force, and there are Z bosons and W bosons related to the nuclear interactions. So all these together constitute the standard model of elementary particles. We have looked into the different particles of quarks and different groups of leptons, and we have tried to understand their basic features. So as of now, the elementary particles can be broadly stated to be these particles. We have seen that proton and neutron are not really fundamental. They are still constituted by these quarks. We have gone through a very broad picture of how these concept of elementary particles evolved over time. So just have a quick understanding about this elementary particles and the broad idea about how these particles constitute different other fundamental particles like proton and neutron. I hope this portion is clear for you. Thank you.